Okay, look, I hope you had a chance to try that, okay? In other words, what were we doing? I said to you, look, there's our NOR gate. What's the function of the NOR gate? Y is A or B, bar over the whole thing. Applying De Morgan, that's really A bar ANDed with B bar. So really, this could be implemented, what, with an AND gate with bubbled inputs, A, B, okay? So this is an equivalent of this gate over here. Now what I'd said to you is, okay, could you now put this in to our circuit of cross-coupled NOR gates and come up with a new gate configuration for an SR latch? Okay, so here is our equivalent. All right, there's the NOR, there's the equivalent. What we're doing then is we're replacing this NOR gate here really with this AND with inverted inputs. So let's have a go at doing that then. So I'm going to put these two guys down. All right, so here we go. There is my AND gate, inverted inputs here and here, like so. Here is the next one, inverted inputs here and here. So this is the NOR equivalent. So this is an AND with inverted inputs. Okay. Of course, this would be S, this would be R. This would be Q, this would be Q bar. All right, let's take this output, feed it back like so. Let's take this output and feed it back like so. All right, so that's our first step. All right, so this circuit then is equivalent to this circuit over here. Direct replacement then of that NOR gate with that AND gate with these inverted inputs over here. All right. So let's see if we can take this just a little bit further, okay? Now, let's have a look at this output here. Where is it connected? The output comes back, comes to the bubble. What is the bubble? It's just an inverter going into this AND gate sitting here, okay? And in the same way, I could look at this output, comes back around, inversion, and then into this AND gate sitting here, all right? So look, could I redraw this? Well, let's have a go at this, okay, in terms of redrawing this. Okay, so here we go. Here's my first AND gate. Here is S. Here's the other AND gate. Here is R. Here's the output. Now, look, what happens to this output? It goes through an inverter. How about I put an inverter sitting there like this, okay? And then I'm going to take this guy, I'm going to feed it back in like so. You see that's the same? Isn't that the same? Here I go. Look. AND gate, inverter, into the AND. AND gate, inverter, into the AND. It's the same thing, isn't it? So let's do the same thing with the lower gate. Put an inverter sitting here. Okay. And I'm going to connect to the input like so. So AND gate, inverter, connected to the input. AND gate, inverter, connected to the AND on the top. Okay? So what I'm saying to you is that this is another way of drawing that. Now let's ask a question. Where is Q? Where is Q bar, having drawn it this way? Well, remember the output of this gate here, the AND gate is Q. There's the output of the AND gate, so that's really got to be Q, hasn't it? The output of this AND gate is really what? It is Q bar. Okay? That's Q bar sitting there. So if that's Q, what's this? Yeah, that would be what? Q bar. If this is Q bar here, go through an inverter, this must be Q, mustn't it? Okay, now look at this. Surely an AND with an inverter is what? A NAND gate. AND with an inverter is a NAND gate. So I really could redraw that circuit now, couldn't I? As a NAND here. Okay, so let's go ahead and do that. Okay. And so we have what we've just done. Now let's combine this. Let's bring this inverter and basically combine these two into what? A NAND gate. All right, so let's do that. So what have we got here? Well, we've got a NAND gate sitting here, haven't we? Okay, the output of the NAND gate is called Q. There it is, output Q. Bubble here, that hasn't changed. That is S. NAND gate sitting here. Why is it a NAND? Let's look at this. AND followed by an inverter is a NAND. This output is Q bar, okay? bubble here on the R line hasn't changed. And we're taking what? We're taking this output, feeding it back. Here it is, this output, feeding back. Okay, this output, feeding back. So there you go, this output feeding back like so. And so now there we've built our SR latch out of what? Cross-coupled NAND gates. Okay, S comes in, inversion before going into the NAND. R comes in, inversion before going into the NAND gate. And so this now is our SR latch, really with NAND gates. Okay, just an alternative implementation of really that SR latch. All right, let's go back to our state machine again, all right? Now, basically I'm going to use an SR latch then really to do what? Well, somebody's going to press the button. We want to sort of latch that signal in, don't we? And then really we want our state machine to perform a resetting function at an appropriate time. So the question is really, what do I do over here? You know, in other words, how do I use that SR latch with, let's say, a push button type switch in order to provide the input into really this combinational logic, or as an input into my complete state machine here. All right, now look, there can be a confusion of terms here. S, yeah, look, S. Well, maybe we don't want to really call this S anymore to not confuse it with, if you like, the S input of an SR latch. Okay, so perhaps we could call that something else. Maybe I'll call that, I don't know, let's call it SW, okay, or something like that, okay? To differentiate it from, if you like, the S of the SR latch. So let's think about this now. How are we going to deal with this part right here? Okay? All right, so I've basically got this SR latch. All right, now what we'll do now is we'll kind of draw this more in a sort of a symbolic way like this. Here is my SR latch. And I've got an output, I'll just show the one output Q coming out of that SR latch. We know now what's inside of this symbol here. It could be our cross-coupled NOR gates, or it could be cross-coupled NAND gates, all right? So there is my SR latch. Now, I've got to think a little bit about this. How am I going to get this input? Where's it coming from? Okay, it's coming from, let's say, a push-button switch, all right? Let's look at that. Push button switch. All right, how do I get a logic level 1 and 0 with a push button switch? Well, really, I'll model the switch this way. It's a single pole, single throw type switch. All right, you get two kinds. We spoke about this before in the previous video. We can have a normally open switch, we can have a normally closed switch. All right, well, let's imagine it's a normally closed switch. So there it is, normally closed. All right. When you push the button, you open it up. When you take your finger off the button, it closes. One terminal, I'm simply going to tie to ground. The other terminal, of course, I'm going to tie to a resistor, and then up to 5 volts. I'm going to take the output at this point here. Maybe I can just connect like so. Yeah, that looks okay. This could be a 1K resistor, or it could be a 470 ohm resistor, or whatever, okay? So here we go. All right. Now, when the switch is closed, normally closed, I'm not pressing it. What's this input here? Direct connection to ground, isn't it? Yep. When I actually press it, what happens? Okay, this guy opens up. All right, if this guy opens up, this is no longer connected to ground, so what's this voltage here? Well, if there's very little current going here, which there is, what's this voltage here? Very little drop across that resistor, so this rises up to 5 volts or becomes a logic level 1. So when you press it, you get a logic level 1 here. Well, that seems to be okay. All right, that's not a problem. Now we've got an issue with the reset. Where is this reset coming from? Okay, this reset input, where is it actually coming from? Now we're going to say that that reset is really going to be coming from the state machine itself. Okay, so the reset is coming from the state machine. Okay? All right. Now, let's look at the case where you might have a normally, if you like, open switch. How would we deal with that? Okay, here is the case where the switch is normally open. You haven't pressed it. That is our condition. When you press it, you close it. When you take your finger off the button, it opens up. So look, normally this is going to sit at what? When it's not being pressed, well, of course, there's no connection to ground, so therefore this is going to sit at a logic level 1. Now maybe, and we've got lots of options, but look, maybe we want a situation, okay, whereby when you press this switch, okay, basically you want the logic level 1, you want to set your SR latch, and then when you take your finger off the button, you want this guy to go to a 0. Now if that is what you want, well, maybe that's a simple fix. You could simply put an inverter here before going into the SR latch. Now once again, you could say, well, where's this reset coming from? Well, you could say that this reset is coming from the state machine, okay? So it's being generated, if you like, in a given state. Now, you do have a potential here, though, that somebody could be pressing this button, causing a 1 over here, and the state machine could be trying to generate a 1, therefore trying to reset the SR latch. So maybe you want to make the state machine inhibit, let's say, this S from occurring, or this S being a 1 over here, so that if you're in a given state, you generate that reset takes priority over anybody pressing the button again and causing, if you like, a 1-1 condition here. How could you fix that? Yeah, look, you could maybe use some kind of an ANDing operation there. Let's look at that. Okay, let's have a look at this situation. Now we've got the SR latch sitting here. What I've done is I've put this AND gate, all right? Now look at what's going into the AND gate. Well, look, I've got the reset line going to reset. This is coming from the state machine, but it's also going in where? It's bubbled, so this gets inverted before it goes into the AND gate. Now let's look what happens here. Supposing that state machine is generating a reset, so it generates a 1 sitting here. Sure, we want this to reset the SR latch. We want the Q to go to 0, okay, as a result of this reset. Well, let's look at the other side. A 1 coming in here gets inverted. It's now a 0 input to an AND gate. What's it going to force this guy to be? Doesn't matter what this input over here is. What's this going to be? Yes, it's going to be a 0, okay? It's definitely going to be a 0. On the other hand, if this reset from the state machine were a 0 sitting here, then that gets inverted. You've got a 1 input over here, okay? A 1 input over here. Now, if this were a normally open switch, remember what did we do? We said, well, we want to go through an inverter before going in here. All right, well, that's easy enough. We'll just go through an inverter like so, okay? And so now we have a situation whereby reset from the state machine takes priority over the person that's pressing the button over here. So if this button was pressed sitting over here, okay, that's a 0 sitting here, a 1 on the other side of that AND gate. But if this were a 1 here, it forces a 0 on this side, forces S to be a 0, okay? Now, look, we're about finished with this particular part here. What I want you to do, okay, before starting part 4, is I want you to convince yourself of what I've done here, okay, as a workable solution whereby the reset from the state machine basically forces this S to be a 1. When the reset from the state machine has not been generated, in other words, this is a 0 coming in here, what's the other side here? It is a 1, isn't it? And so if somebody presses the button, will this indeed cause this S to become a 1? Now think about that. A 0 on this side, because let's imagine the state machine is not generating the 1, it's generating a 0, okay? We're not in the state where we are initiating that reset. So that would be what? A 0 this side, a 1 this side. Somebody presses the button, closes, what's this voltage? A 0. The other side is a 1. I've got a 1, 1, which will cause the S to go to a 1. I want you to convince yourself of the operation of this little circuit here. Understand the function of that gate now, what it's actually doing, okay, and see if you can explain it perhaps to another student or to somebody else. By way of explaining this to somebody else, I think you'll be able to say that I understand what's going on. Okay, we'll take a break.